Okay, so we're going to be building a program to control basically balancing a ball on a beam based on two inputs. One input is the position of the ball, and one input is basically an adjustable set point. And I think what we'll do is we'll start by getting it all running, and then we'll just focus on the single input, and then we'll modify it to add in the set point. Okay, and the purpose of this activity is to really learn about PID controllers and having a control loop. And this idea that when we have, when we're trying to control something in the physical world, we have to deal with things like inertia, where these objects have velocity, and it takes time for that velocity to change. Or, in this case, we're looking at the motion of an object, but there's other systems, things to do with temperature that also kind of have inertia, and you have to use a similar type of control system to account for the fact that when you make a change, it takes time for that change to take effect. And so in a control system where you don't take into effect those changes, what you can end up with is a system that oscillates around your set point rather than going to that set point. And so if you just have like a proportional control, which is the P of the PID, you'll be potentially oscillating back and forth. Okay, and so we'll go ahead and build this out, but first thing we got to do is we got to build out some functions to read our sensors. And so we're going to use some types here. I'm not settled on what types I want to use yet, so we'll start with using integers, and we might change them later. Okay, so we're going to have functions to read our sensors, and then a function to control the servo, or a function to take those readings and to turn it into an output for the servo. Okay, so we're going to say int read sensor 1, and so this sensor is going to be an ultrasonic sensor, and so it's going to send out a ping, and it's going to wait till it gets a signal back, and based on that time it does a calculation for on how far away that object was. And so we're going to let's see, so we'll have a long for the duration. Yeah, let's see, that is long. Okay, well, we might change this to from an integer later. And then we're going to have a float for the distance. And then we'll say we're going to have pins to connect it, so we'll have const int trig pin 1. We'll set that to 2, and const int, not trick, echo pin 1, and that will be set to 3. We'll set these as outputs, so we're going to say pin mode trig pin 1 output. And the echo pin should be an input, right? So pin mode echo pin 1 should be input. Okay, and now we're going to do a digital write here. So we're going to send that trigger pin high to send out our signal. So we'll say digital write trig pin 1, and so we're sending out our pulse. We're going to delay delay microseconds, and we're going to delay for 2 microseconds, and then we're going to do a digital write low. Oh, we want to write to low first. Apologies. And then we're going to delay 2, and then we're going to write to high. And this sends out our pulse. And then we're going to write it to low again. And so we basically create a 10 microsecond pulse. And then we're going to, this would be a high frequency sound that's being pulsed for 10 microseconds. And then we're going to find the duration by waiting until we get a pulse in. And what this pulse in function does is it's going to wait until it gets a response from the echo pin. And so echo pin 1, and we want to set that one to, we want that to come in high. And so one of the potential issues we have here is that if the object, if the we don't get it, like if the sensor misses the reflection, this is a blocking function, and so it might take extra time. And this is something that could really affect our control loop, in that when we have a measurement that takes too long, one, it's going to give us a bad value because it's missed the target, but also it takes more time. And so we're kind of hoping and trying to make sure that for our control loop to work smoothly, we're getting the same measurement, we're getting our measurement every so often. And so this here is something that could cause a problem for us. There's other kinds of distance sensors, but for our purposes, these ones are fairly precise up close and in the range that we want to use them. And we don't necessarily want to spend a lot of money on distance sensors in order to accomplish this, but we may find that later we need to choose some different sensors to get this to work. Okay, so we got our duration. We can then calculate the distance. So distance equals duration times 0.34 divided by 2. Okay, I'm going to say return distance. Okay, something else that we can do later. So when we do this, we're taking our duration, which is a long, which is a type of integer, a whole number, and we're converting it into a float here. Floats in general are going to be take more time for computation. I don't think it's necessarily going to be an issue here, but because we're not doing super heavy computation, but because we're also reading another sensor to get our set point, what we might find is instead of actually converting this back to a distance, we may choose to instead return the amount of time it took to come back, and we're just compare those values. And so because of the way the PID works, as long as we're consistent about the values we're comparing from the two sensors, it shouldn't necessarily matter. And so we may decide to use the duration as our set point instead of the distance, and that might make the calculations a little bit easier. Okay, so we want a second function to read the second sensor, and so we'll copy these so we get pins for the second sensor. We'll call this pin 2. We'll set those as outputs and inputs as well, and we'll just modify this function here to use the second set of pins. So now we have two functions to read the sensor. So every time through the loop, we're going to say get our first sensor. So we'll say int let's do the float. Let's change these to be floats for now. So we'll have the return values of floats for our functions since we're returning the distance. Float, and we're going to say float. Let me see. All right, current value equals read sensor 1 float current value equals read sensor 2, or we'll call this the set point rather. Set point. And then what we want to do is we want to take that set point and the current value and get our servo position. Equals, and then we'll have to make a function here. So we're going to make a function to get the new servo position. New servo position, and we're going to pass in the current value and the set point. Okay, and so I'll make that function here. Get new servo position, current value, and set point. And so we'll have to go back, and this is the meat of all this, right? This function here is taking these two values that are floats and turning into a position to write our servo to. And so the servo is going to control the position arm. And so by writing out, using these, we're going to get the new value for that servo. Okay? And so for now, we're just going to return 90, and then we'll have to implement this later. This is where we're going to be calling our control loop and keeping track of our past measurements and things like that. Okay? But for now, we just want to get everything working. And so we're going to go, let's go ahead and import the servo library. So we have the servo. I think it's just servo.h. And then we're going to make a servo control servo, and we'll do attach it. So servo dot attach, and we'll set a servo pin. We'll set that to, oh, I gotta fix these. So 2, 3, these will be 4 and 5, and we'll set this to 6. Okay, so we'll attach it to servo pin. And then here, we'll go ahead and do control servo. So this should be control servo.attach and control servo.write and servo pin. Okay, let's make sure everything compiles here, and then we'll do a print statement to debug. So I'll do serial.begin. Oh, notice I got something. Current value was not declared in this scope. Current value. Oh, here we go. I set those as integers or floats. Okay, what else do we get? Servo. Okay. Yep, I think that was just the one error. Yep, okay. And then serial.begin 9600. So we had an error because we passed these to the function without setting their types. And then we'll do serial.print. And what we'll do is, to make life easier on ourselves, we'll make a character buffer of, we'll say 60. Well, we might fill up the memory on this one here, so we'll see. We'll include string.h. We'll see if it lets us do this. Okay. Do sprint f buff sensor 1 percent f sensor 2, and so this is a shortcut to kind of combine this as a string here. Let's see if it lets us do it. So we have the 2 readings from the sensors, and then we're going to display the servo position. And then we will leave out the new line. We'll let the new line come right here. This saves us from doing a bunch of print line statements, or printf, or serial print statements, and the trade-off is that it uses a whole bunch more program space and memory. And so we might find that we run out of space, but for now, this will be helpful to get things going. So we'll have current value, set point, and servo position. Okay, and we'll put a %d here because that one is an integer. Okay, and then I can pass that buffer here, and hopefully it's gonna let us do it. Let's see. All right, and so now we got kind of the basic structure of our program. Okay, let's see what it says. 16 bytes, or 16% of program storage, 12% of memory. That's not too bad. Okay, so we're going to keep that there. Let's see if it works. We'll test in the simulator now. So I'm going to copy this over to the simulator here. Code, text, continue. All right. Okay, before we can do this, there's some mistakes that we got to fix. First of all, here, this should be, I was off by 10th place there. And here, when we do our distance calculation, okay. And then coming up to here, this worked for the servo position, but not for the these values that were flowed. So for some reason, well, there's a couple reasons why that might happen. We won't get into it here, but what we're going to do instead is we're just going to do our print statement. So serial dot print, and then we'll put in this first part here, and then we'll put in the current value, and then we'll put in this part right here. In quotes, let's see. And then let's go, dot print, set point, and then let's see, serial dot print, this part here. And then finally a serial.print line, ln quotations, oh, no quotations, servo position. Okay, so we got that. We're going to go ahead and delete this line here because we don't need it anymore, and that one right there. Okay, and so let's copy this in to our simulation. There we go. So we got it reading the two positions, and so I can adjust those positions here, like that, and then eventually we'll have it sending a value to the servo based on those readings. Okay, and interesting. I wonder how much time this is taking. So this is, I wonder if this is just the simulation is slow, or this is actually how long it takes. I wonder if we get these values closer, it'll go faster. Okay, yeah. So definitely you can see, like, if I make this go further and so the time takes more time to come back, you can see that I run into a situation where these values are taking longer. And this one is even like maxing out here. And so that's one of the challenges with using these sensors. We got to be really close. And so when we're close, it goes pretty fast, and it should be fast enough for what we want to do here. Okay, so we'll stop the simulation there. Everything's working. The next step will to be build out the our control function here, the get new server position, and to add some timing in here so that we make sure we don't make sure we do this on a uniform interval. Okay.